We need to solve the system of inequalities y is greater than or equal to 3x minus 1 and y is less than or equal to 1/2 x by graphing. Then we need to select the best possible choice from the 5 given answer choices. Remember, when we solve a system of inequalities, what we're looking for is the region in which the shaded solution areas of these two inequalities overlap. So in order to find that, what we need to do is graph each inequality separately, but on the same coordinate plane, and then we're going to look for the area that the two shaded regions overlap. So let's start by graphing this first inequality, y is greater than or equal to 3x minus 1. To graph this inequality, we're going to start by graphing the line y equals 3x minus 1. And the easiest way to graph a line like this is to find 2 points that are located on the line and then just connect them. So let's start by plugging in 0 and 1 for the values for x and then solve for y so that we can come up with 2 points that are located on this line. When we plug in 0 for x, that gives us y equals 3 times 0 minus 1. 3 times 0 is 0, and 0 minus 1 is negative 1. So that tells us that the point 0, negative 1 is a point on the line. Now we do the same thing, but instead of plugging in 0 for x, we're going to plug in 1. That gives us y equals 3 times 1 minus 1. 3 times 1 is 3, and when we subtract 1, that gives us 2. So now we have the 2 points, 1, 2, and 0, negative 1. And now that we have these 2 points, what we're going to do is plot them on the coordinate plane and then connect them. And it's important to note that we're going to connect them with a solid line. And that's because the inequality that we're representing here is greater than or equal to. Remember, when we graph inequalities, if we just have less than or greater than, we use a dashed line to show that the points that are located on that line cannot be solutions to the inequality. But in this case, we have greater than or equal to and less than or equal to, so we're going to use solid lines for each of them to show that the points that are located on those lines can be included in the solutions. So now let's plot these 2 points and connect them with a solid line. Now that we've graphed the line, we need to determine which side of the line is going to be shaded to show where the solution area lies. And remember, the way we do that is by picking a point on one side of the line or the other, and then plugging it into the inequality to see if it comes out with a true value or a false value. And the easiest point to plug in, as long as it's not located on the line, is always 0, 0. And in this case, 0, 0 is not on the line, so we're going to use that. When we plug in 0 for x and 0 for y in the inequality y is greater than or equal to 3x minus 1, that gives us 0 is greater than or equal to 3 times 0 minus 1. 3 times 0 is 0, and 0 minus 1 is negative 1, so that gives us 0 is greater than or equal to negative 1, which is true, because negative 1 comes below 0, it's less than 0. So now that we know 0, 0 works in this inequality, that tells us that any point that's located on the same side as 0, 0 is also going to be a solution. So we're going to shade this entire portion of this side of the line here to show that all of these points are going to be solutions to this inequality. Now that we've graphed this first inequality, what we need to do is graph the second inequality and then determine where the shaded regions overlap. And that's going to tell us the solution to the system as a whole. So now let's graph the second line and do the same thing we just did for y is less than or equal to 1/2 x. Remember, we start by graphing the line y equals 1/2 x, and we do that by plotting 2 points that are located on the line and then just connecting them with a line. And this time we're also going to use a solid line because we have less than or equal to. When we plug in the value 0 for x, that gives us y equals 1/2 times 0, which is 0. So we know that the origin, or the point 0, 0, is located on this line. When we plug in 2 for x, that gives us y equals 1/2 times 2, which is 1. So we know that the point 2, 1 is also located on this line. Now we're going to plot these 2 points and connect them with a line. Now that we've graphed the line, we need to determine which side of the line is going to have shading. Now remember last time we used the point 0, 0, but in this case we can't use this point to test whether it's going to give us a true value or a false value because it's located on the line. So we need to pick a different point. And the next easiest point is going to be the point 0, 1. When we plug in the point 0, 1 into the inequality, that gives us 1 is less than or equal to 1/2 times 0, or 1 is less than or equal to 0. We know that this is false because 1 is greater than 0. So that tells us three things. This tells us that the point 0, 1 is not a solution to this inequality. It tells us that if this isn't a solution, then neither are any of the points on this side of the line. And it tells us that if none of these points are solutions, then all of these points are solutions. Now that we've graphed the second inequality and we have the shading for it, let's pull up the shading for the first inequality again. And now when we have both inequalities graphed at the same time on the same plane, we can see that the solution area to this system is going to be this area here where the two solution areas overlap. So the final answer to problem 11 is A.